All right, so everybody can see my screen, right? I have a PowerPoint here. Let me go to the place that we stopped last time. I think we was talking about a functional dependency. So let's start slideshow from that slide. Show from current slide. Okay, so here that's what we stopped last time. So suppose you're given a table and you want to decide which column depends on which column. So basically functional dependency concept is this. Just say, for example, given a student ID, and that student ID should be uniquely determine the student name and the major, right? So therefore, in this case, we say name and the major are functionally dependent on student ID. So that's what it means here, okay? You can say it in two different ways. You can say either student ID functionally determines name and the major, or course number functionally determines title and credit, or oppositely, you can say name and the major are functionally dependent on student ID. Does that make sense? All right, so we have another table. And for this table, we said student ID, student number should be able to determine everything else. So that's easy to tell because basically student number is like a primary key here, right? I think the same thing happens to a student social security number. If you know social security number, then you should be able to uniquely determine student number, student last name, first name, middle name, and everything else, like major, GPA. Can you imagine that, right? So same thing happen if I know the zip code, I should be able to uniquely determine the city, right? Because every city have a multiple zip code, but each zip code belongs to one city, okay? And the same thing for major. If you know major, then you should be able to tell that which department is offering the major, offering the program, right? So major should functionally determines department, okay? And so that's why we have those kind of functional dependencies. Now, if I change this, let me go to, if I'm going to use same table, and then ask you whether additional functional dependencies may exist. Okay, so I'm going to use whiteboard here. So what is this one? So I'm going to get rid of this. Need that. Clean up. Okay. So suppose I have a functional dependency, which is student ID and last name. Would that be functionally determines first name? It's last name. What do you think? So given the student ID and the last name, then you will be able to tell who is the first name, right? So this function dependency also exists. Okay, now let me give you this one. So suppose I know the last name and the first name. Will I be able to tell the student major? Yes or no? So in this case, it would be problematic because there are many people who have the same identical last name, first name, right? But they have different majors. So in this case, last name, first name cannot uniquely determine the student number. So this functional dependency will be incorrect, and this one was correct. All right. So now let me ask you this. Suppose I have last name, first name, and also street address. Will that be able to determine the student major? Yes or no? So now you ask whether in the same address you have last name, first name. Can you have the same two people with the exactly same last name, first name? in the same address? That's possible, because a lot of times you find that fathers and the sons, father and the sons may have the same name, the same last name, first name, right? So if it happens that both of them have both of them are students of University of Akron, then they will have they may have different majors. So this is not true. So same thing, last name, first name, street address, so should not determine student ID. So basically, this last name, first name, and street address are not unique, are not uniquely determine the street address, the student number, the particular student, right? So this is also the functional dependency is also wrong. Okay, so we can move on. So based on that, we analyze that this functional dependency should exist. Okay. Now, because of functional dependency, we know that there's a concept of a key, right? Or primary key. What is a primary key? Primary key is just one or more columns whose value can uniquely identify the records in the table, right? That's a primary key. But now we say that if I know a value of a student ID, I will be able to uniquely determine all other values. So essentially, we can use functional dependency to define a concept called a key. So in general, we can say a key or candidate key is one or more columns whose value determines the value of all other columns. So in other words, the key column or columns will functionally determine all other non-key columns, or other key columns, or other columns. So those are non-key columns, of course. Make sense? So now the question is, a table may have multiple such candidate keys, right? So like a previous example, student ID, student number can uniquely determine everything else. So let me go back to previous one. So for example, in this table, we have functional dependency between student number and everything else, right? So student number in this case should be a key. And same thing with social security number. Social security number can determine everything else also, right? So in this case, this table may have two candidate keys. You can use social security number as a key or student number as a key. So they both will be candidate keys. However, you only pick up one of them as their primary key. So essentially, you're going to choose either student number or social security number as their primary key for this table. So remember, a table can have only one primary key, right? But you cannot use a major as a primary key, because the major only determines department. Major does not determine social security number, does not determine first name, last name, right? Because inside the same major, like IS, you may have many students with the same major, right? So major cannot be a key. It's the same thing, zip code cannot be a key either. Even a zip code can determine city, but zip code cannot determine everything else, like date of birth, GPA, major, student name, last name, first name, or etc. Okay, so now if you have multiple candidate keys, how do you choose a primary key? Which one you want to choose a primary key? So basically, this slide just tells us that a key can be defined by functional dependency concept. Okay, this is just like a related concept. So candidate key is one or more columns whose value can uniquely determine all other non-key column values. So in other words, the key columns will functionally determine all other columns. All right. So if you have multiple keys, which one to be? Oh, by the way, let me look at it here. Okay, so we said the student number should be key, candidate key, and then student number should be also social security number should be a key, right? But you can also use student number, for example, last name, add last name, or last name, first name together to determine everything else, right? However, in this case, we say that this, even though this is a key, the student number plus last name, or student number plus last name, the first name, keys are candidate keys. However, they are not really essential keys. They are not the minimum keys, because by getting rid of last name, by getting rid of last name, first name together in the last line, you can still have a key, right? So in this case, last two will not be a good candidate key. They are just essentially they are not a minimum. Okay, so minimum key is the concept that of the key that you cannot remove anything from it. For example, student number, you cannot remove anything from it because there's only one column in here. Okay, but for the last one, you can remove last name, first name. So therefore, the last one is not candidate, is not a minimum key. Okay, so a key is called a minimum if not always a subset is a key. So student number, these are not, they are minimum. Sorry, this is misspelled. And then this one another minimum. Okay, so how do you choose a primary? How do you choose a primary key? Only minimum key can be selected. Okay, the first you want to make sure that. Okay, secondly, you want to choose a candidate key whose value does not frequently change. Does that make sense? Whose value does not change. For example, can we use student email address as a key? Often you find that email address for each student is unique, and email address will be able to uniquely identify student names, majors, GPA, birth date, all that. However, that candidate key is not, that even though it's a candidate key, however, you should not choose email as a key, because a student often in the lifespan, they will have a lot of different email addresses. So when you go to University of Akron give you email address. If you go to another, go to employer, you join the employer will give you a new email address, right? So essentially your email address is actually constantly changing. So therefore you should not use email address as the primary key. Thirdly, you should choose primary key that does not have privacy and security concerns. So like a social security number, that companies, some like banks or some rental company, they often use your social security number to identify you, to look for your financial information. So that the social security number is really not a good choice for primary key. Primary key, is often you have to pass around, you have to kind of tell people, but it's not a good idea to tell social security number to anybody. Right? So that's just you know that we had this instance that a professor in economics, I think that was 20 years back. At that time, the university was using social security number as student ID, and then that professor was just like garbage. He used many students' social security number to apply for credit cards, and then charge those credit cards without paying back, and then that guy was actually captured and put into prison. So since then, the university changed social security number to change the student ID to non-social security number. So now you all have like 7-digit social security student IDs, which have nothing to do with social security numbers. All right, so just make sure that don't choose anything that has privacy or security concerns as a primary key. There we go. So now let's talk about normal forms. Regarding that, does anybody have questions so far? Functional dependency concept is very, very important, okay? So you will need to probably just look up a couple of tables to see whether you can identify some of the functional dependencies, and then you say whether you identified it correctly or wrong. So in this chapter 11, I have many of those tables, and then you will be able to tell whether you pick up right or wrong ones. Okay, the functional dependencies are determined incorrect or correctly. Okay, so we are going to so-called normal forms. Remember, normal forms just simply a criteria which will be used to make a judgment on whether a table is having extra redundancy or not. Okay, so if I say a table has, if a table is in a normal form or conform to the normal form, is basically we can say either way. We can say a table is in the normal form or table conform to the normal form. Okay, so sometimes the table may conform to one normal form but fails other normal forms. If a table is in the normal form, it means that table does not have actual redundancy according to the normal form. Okay, if table is in a normal form, that means according to that criteria, the table is okay. The table does not have actual redundancy. But if a table fails the normal form, then it means the table have actual redundancy to be removed. Make sense? All right, so I forgot to mention that regarding normal forms, we have, I don't know how many, probably tens. If, several years back, I took a computer, many years back, actually, 20 years back, I took a computer science database, and then the whole book, has many different kind of normal forms. And also, we look at the research articles, more articles talking about different kind of normal forms. Okay, so what the essential ones, the most useful ones will be the ones we are going to talk about. So the second, third, and the Boyce-Codd normal forms. We'll be talking about that just a second. Okay, so for each normal form, this is how you are going to study, to learn, and to give you a study guide. Let me give you a study guide just a second. Okay, first, let me say if a table fails normal form, then what do you need to do? You need to fix it, right? So you need to break up the table into smaller tables so that each smaller table conforms to the normal form. Okay, we'll talk about the advantages of big tables versus small tables. So big table usually will have actual redundancy. Smaller tables tend to have less redundancy. So if a table is not in the normal form, then we have to break it up into smaller ones. Okay, now there is a possibility that after you break it up, the table may still fails the normal form. Okay, so especially when we talk about second or third normal form and the Boyce-Codd normal form, that's possible. There's a possibility that when you break up the table into smaller ones, the smaller ones can still violate third normal form or Boyce-Codd normal form. Okay, so if that's what happens again, then you have to break it up again into even smaller ones. So this process, breaking up table into smaller ones may not just stop at one shot. Okay, and this process continues until all smaller end result conform to the normal form. All right, so this is the study tip I was talking about. Also, there are tens or maybe hundreds of different normal forms. The ones useful are just those ones we're going to study. The chapter 11 cover that. Okay, and then for each normal form, make sure you understand the definition of the normal form. Does it make sense? Just me trying to understand what is normal form is defined, definition, and then know how to apply the definition, or maybe a shortcuts. Okay, sometimes there are shortcuts. Without using definition, you can still make a judgment to see whether the table is in a normal form or not. In other words, whether normal form has actual redundancy or not. Okay, and finally, for each, if table is not in the normal form, then you need to know how to fix it. Okay, you need to know how to fix the violations. So those are the three things you need to pay attention for this lesson. Okay, so we may not finish everything today. So basically, we're trying to do first, second, and maybe third, but then we'll leave a Boyce-Codd normal form to the next class. Okay, but for each normal form, make sure you understand the three: definition, how to make judgment, and how to fix if it has violations. All right. So first normal form. This is actually very simple ones, and that's what if you remember that for very first day class, I said each cell can have only single value, right? Each attribute corresponding to all attributes must be single valued. Okay, so in other words, you have a table, then each cell must have single value. So that is exactly the first normal form. Okay, so theoretically, this is how the definition defined the first normal form. A relation contains no repeating data. A relation contains no repeating data. So basically, just basic concept is that so each cell has only single value. Okay, and all attributes are dependent on the primary key. So there must be a primary key for the table. So if a table does not have primary key, then it violates the first normal form also. Okay, so all attributes must depend on that primary key. So how do you check? So basically, of course, if there's table, if table does not have primary key, then you have the final one with primary key. So that's easy fix. And then what if your table or column has multi-values? And we know how to handle multi-values, right? Multi-valued attributes, for example, an employee may have multiple dependents, or student may have multiple majors. How do you handle that? So you are going to use a weak entity concept to handle that, right? So multi-valued columns out, take this, for example, majors out into separate table. Okay, so that's how. Let me give you an example here. So here we have a publisher, publisher books, phone, address, and city. So each publisher, of course, has a publisher name, has a phone, has address, has city. However, the publisher may have multiple books, right? Publisher may publish multiple books. So for example, Macmillan published 3 books, and Edison 1 book, and McGraw-Hill has 2 books, and Oracle has 1 book here. Okay, so in this case, we have a books column which is multi-valued, right? So how do we handle that? How do we fix this violation? So this table does not conform to false normal form. So we will take this out, okay, to make a separate table. How do we do that? This is how we do it. So basically, we are going to take that attribute out, say the title, the book titles as a column, and then also we need to make like a book number. So each publisher has a book number, right? Give back sense here. Each book. So for example, Macmillan has a book 1, 2, 3, and then Edison has a book 1, and McGraw-Hill has book 1, 2. So those are book numbers. So attached to each title, you just add a number. Okay, but that number is not a unique key. It's not unique because each publisher has a book 1, each publisher has a book 2, some publishers have book 2 also. So there's 1, 2, 3. Only relatively identify the book relative to the publisher. It will not uniquely identify across all books published by all publishers. Okay, so this is the weak entity, right? Now, essentially, this is how we handle, we split that into 2 tables. So, who is joining? Who is joining? Guest is joining. Who is joining? Can you hear me? Okay, so anyway, so we are going to have 2 tables. The first table is just, after you remove this column, then everything, make up the table. And then for the weak entity table, yeah, then you're going to have a book title column and then number column like that. And also you need to duplicate the primary key from one side to many side and make that a primary key, the foreign key as a part of a primary key, right? So essentially, you're going to have a publisher name also duplicated in here, okay? So then this table is going to have a primary key consisting of publisher and a number, both columns, right? That's how we handle that using weak entity concept. All right. So false normal form violation will be handled as such. Okay. So in the future, so that's the first thing you have to do. Okay. If a table violates the false normal form, if it does not have primary key, pick up a primary key. If it has a primary key but it has columns like this, like books, have multi-valued attributes, then you have to use a weak entity concept to handle that, to break up into 2 tables. Okay, now let's talk about the second normal form, which is the more essential ones. Okay, the second normal form basically has this definition. Okay, first of all, it has to be false normal form. A table is in the second normal form if it is in the first normal form first. If the table is not in the first normal form, of course, it's going to be not in second normal form for sure. Okay, so the definition relies on the first normal form to begin with. Secondly, these are the more essential ones here. Okay, so what are essential? So there's no functional dependency between a part of a primary key and another column. Now, the keyword is a part of a primary key. Okay, I'll use example to that. So sometimes a table may have just one primary key column, right? So in that case, part is a whole. All right, but if a table has a multi-column primary key, like a composite primary key, then you may have parse. So if you have functional dependency between a part of primary key and other column, then you are violating the second normal form. Okay, so explain to that. Okay, no attribute is dependent on only a portion of a primary key. So that's the second normal essential condition of second normal form. Or equivalence in all non-key columns should describe the entire primary key, but not a part of a primary key. Now, this is the concept. When we come back to this concept again. But first of all, let's use the example to understand that. Okay. Let's see. I'm going to use the example here. Good. So here we have a table like author ID, author name, city, state, title ID, title, royalty. So this table is used by publishers to keep track of royalty. Royalty is just like when an author writes books, right? And if a book is published, then the publisher is going to pay to the author. So you understand that one author may have multiple books, multiple titles, okay? But one title may have multiple authors too, right? Joint authors, right? So in this case, you're going to have a table which will have basically have a student author ID and a title ID, both of them together as one primary key, composite primary key. But in this case, you'll say that author ID is only part of primary key. However, author ID will determine author name, will determine city and the state, author state, author city, right? So that is a part of primary key, determines other columns. Similarly, you have title ID determines title, right? Title. So title ID determines title. Title is other column, and title ID is part of primary key. So again, you have also partial functional dependencies between a part of primary key and other columns. And the royalty depends on both, right? Royalty depends on title and also depends on author. Okay, so if author write multiple books and different books may have different royalty. If a book has if book have multiple authors, then each author may have different royalties. So royalty depends on both. But all other columns depend on only part of primary key. So this is what it means. And let me go back to the previous slide. Okay, the concept here. So first of all, to be a second normal form, you have to be first normal form, all right? And then secondly, there's no functional dependency between a part of a primary key and another column. If there's one, then you can say that table does not conform to second normal form, okay? If there's no such thing, if all non-key columns depends on the entire primary key, then you can say that the table is in second normal form. Is that clear? So just make sure that you make a judgment based on this definition, the second definition. Okay. So no. So you can just briefly call that as no partial functional dependency. No partial functional dependency. That means no functional dependency between a part of a primary key and another column. Okay. So how do we handle this second normal form violations? First of all, you need to determine what is the primary key for the table. Okay. Only after that you can tell what is part of it, right? And then you need to draw functional dependency diagram. So basically, you can just draw diagrams like on the table, say which column determines which. Draw that diagram. All right. And then you check to say if there's any partial functional dependencies between a part of primary key with other columns. Okay. Now this is using definitions. Okay. The step 1, 2, 3, basically just definition. But there is a shortcut. If the primary table has only one column, then there will be no partial functional dependencies for sure. You know why? Because there's no part of primary key, right? Everything, the part is a whole is a part. Of course, the primary key should determine everything else, okay? And then everything else should depend on the entire primary key because the entire primary key is part of primary key. So there's no part of it, right? So if the table has only one column, then the one column, of course, you can just use this shortcut. If the table has only one column primary key, then you can use this shortcut to determine that the table is not in second normal form violations. Is it clear? Okay, so now let's come back to this example again. So we draw functional dependencies. So we draw from function student ID, author ID determines author name, city, state. So that's how we draw this functional dependency here. See that? Okay. Similarly, title ID determines title. So there's a second functional dependency here. You see my mouse moving, right? Okay. And finally, the primary key, of course, determines everything else. So basically, this is how we show that. So we say author ID, point out, title ID, point out, and that determines everything else. You see that? Okay, so that's basically the concept of primary key, right? Or primary key usually determines everything else. Primary key usually determines everything else, right? So that's what we talk about, the concept of key. Okay, so based on this functional dependency diagram, this is called a functional dependency diagram. Based on this functional dependency diagram, now we can make a judgment. This table is not in second normal form, but it's not in second normal form or has second normal form violations. Okay, because there's a partial functional dependency like this and that. So as long as you have one, so you don't have to have two, okay? So as long as you have one functional dependency, which is between a part of primary key and another column, then you can make judgment to say that the table is not in second normal form. It's not in second normal form, yeah. Make sense? Now, how do we fix it? So first of all, make judgment. This is how you make judgment, right? So since there are partial functional dependency as follows, our table is not in second normal form. Okay, so those are partial functional dependency because title ID is a part of primary key, author ID is also part of a primary key. Make sense? Now, how do we fix the second normal form violations? So this is how we fix. Okay, just follow the procedure. Just remember the procedure. Not remember, just understand the procedure. So it's pretty simple, actually. So your first part is you list every part of the primary key per line. So for that table, we have like every part of primary key. So basically, you have a student ID, author ID, that's one part, title ID is another part, and author ID, title ID together is another part, still another part. So it's trying to list all possible parts of the primary key. So if a table has only 2 primary key columns, then this is what you do. But if a table has like a 3, I'm gonna give you just an example here. Okay, let's say suppose a table has 3 columns as a primary key. Let me just show that. Okay, let's say suppose I have a primary key. Okay, I'm just making up something. So primary key consists of column A and column B and column C, 3 columns. Okay, so now you're trying to list every part of this primary key. So A, that's one part, B, C, okay? Every part is one line. And then you have A and B, A and C, and B and C, right? So now you have 6 lines. And finally, all together, A, B, and C. So if you have a 3-column primary key, then you basically have the right 7 lines like that, according to that procedure. Is that clear? So after that, then we just put all depends on each part of primary key after that part of primary key. So for example, name, city, state depends on author ID. So I put this after that. So just there's functional dependency here. Like that. And then title depends on title ID only. Okay, and then royalty depends on both, right? So therefore, we have 3 lines coming from this second step. Okay, and then each line will make up a table. Each line will make up a table. So first line will make up a table with student ID, name, city, state as columns, and then use the determinant, this determinant as the key, as the primary key. So author ID will be primary key for the first table. Second table, title and title ID will be 2 columns for the table, but title ID is going to be primary key. The last table is going to have 3 columns. Author ID and the title ID will be the primary key, composite the primary key again, and then royalty will be just non-key column. So, and the result will be like this. So this table is violating second normal form. And then we break it up into smaller tables, like that. Okay, So basically this author ID, title ID, and then here title ID, author ID, title ID, and royalty. Okay, so now let me ask you a side question. What is the relationship? So if you're trying to draw like a entity relationship diagram, what is the relationship between among these tables? So you have, so I'm going to show you that. Okay, so let's say we are going to have entity about object about authors. So you're going to have author entity, which have author ID as identifier, and then you're going to have a name, city, and a state. So I will just use name. I just say all required of name, city, and the state. So this table, the first table, is represented by the entity, as we just shown, and then we have a table about titles. So then we'll have entity for that. So title. So title have title ID and actual title. So they may be required. Okay. And then what happened to that last table? This is actually gerund. You see that? This is actually gerund. So basically you have a author ID and title ID as foreign keys coming from respective authors and title to entities. And then they have a separate attribute. The attribute is royalty. So in this case, you actually is consider is have like a gerund in the middle. So I'll put that in here. Okay, we can call that royalty. Royalty. So the column is royalty. Let me just try to write bigger. Let me put it here. Okay, so there's a column called royalty. So the name of the gerund may be also called royalty. Okay, and then this is actually a gerund in the middle. Okay, so only after that, then when you convert this into tables, then you're going to get it author ID into here, title ID into here. So royalty will have 3 columns, right? And the author ID and the title ID will be primary key. So that's how we have this last table. So essentially, you will have violations. You will have second normal form violations if you're trying to combine these entities or the tables for these 3 different things into one. So remember, like this table, the table we just have here. So this table is essentially a combination of the 3 entities, information from all the 3 entities, gerunds, and then two things. Okay. So in general, if you're trying to combine or table 2 entities with many-to-many relationships, or 2 tables with a gerund in the middle, then you are going to have second normal form violations. Okay, so that's why I said if you had followed the procedure as I talked about in the beginning of the class, so we're trying to build a database by following that procedure, starting with data models first, and then convert data models into relational model. Then you're not going to produce a table like this. You're not. Okay, and this happens that when somebody does not have database training and they produce they thought they can do database, right? So everybody can design tables, right? But they thought they can design this table, but actually this table has too much redundancy, and then that redundancy is you understand that if you essentially make this table renders this table useless, right? Because of various anomalies. Okay, so after we identified that this table has second normal form violations, then that's how we can fix it, and we break it up into 3 tables. So end result will be same as converting these ER diagrams into three tables. Okay, so result is equivalent to that. All right, so okay, so This is how we do second normal form violation, this example. And now let's try to do another example, okay? Now, you still remember this example? This is the very first example we talk about the problems or issues with redundancy. Okay, so we basically have using this one table to hold information, to store information about the student and also courses they are taking. Okay, so the table has extra redundancy. We understand that, right? So now let's check to see whether this table is violating second normal form. Okay, so first of all, primary key consists of a student ID and a course number, right? Okay, and then let's try to draw functional dependencies. And we say that student ID, of course, determines student name. If you know student ID, of course, the student name is unique, and the major you can also determine. If you know the course title, your course number, then you should be able to uniquely determine course title and also credit hours, right? So again, this table has partial functional dependencies. Okay. So this one is not finished. Let me trying to do that using whiteboard. Okay, so let's go back to the previous one. So here, let me go to, let's put this up. Okay, so that's just pretty small, but hopefully hopefully you can see. Now let me try and use whiteboard to show the functional dependencies here. Okay. So for that table, we have a PK equals to course number and student number. Okay, so the first step you should do is what is the primary key, and the second step is to draw functional dependency diagram. So we can do that. Just do it in here. So we have student number, student ID, and the student name. Then next one is major, and then we have course number, course title, and the credit. So draw functional dependencies. So basically primary key consists of these two columns, okay? And the student number determines student name and major. So this functional dependency. And the student number, course number determines title and credits. So this table has a partial functional dependency. So this table is not, so we can say this table is not in second normal form. It's not in second normal form because of partial functional dependency, which is student ID determines name and the major. Okay. And then again, course number determines title and the credit. And these are partial functional dependencies. Okay. Dependencies. Thus, the table is not in second normal form. Okay, so after we make the judgment, then we know how to fix. We need to know how to fix it. So first step of the fixing is to list every part of the primary key line by line. So the first part is student ID, second part is course number, and the third is everything else: student number, student ID, and the course number together. Second step, put all the columns that depend on that part of primary key line by line. So we have student name, depend on that, and then student major, depend on that. Course number determines title and the credit. And then what about everything all together? There's nothing, okay? We just leave that empty. Okay, so the second step, the third step is just using each line to make a new table. So now we have a table consisting of a student name, student ID as a primary key, that's determinant with primary key, and the name and the major as two non-key columns. So that's the first table. Second table as a course number as a primary key, title, and the credit. Okay, so now we have a second table. What about this one? This one does not have anything depend on it. However, you still need that table. You still need that table, but basically there's no non-key columns. So you're going to create a table with just two column determinant, student number, student ID, and the course number. The both will be part of primary key. And this is, there's nothing depend on it. So therefore there's nothing, besides this, nothing else besides these two columns. So there's student ID, okay. So if you're trying to draw ER diagrams, you will realize this is actually a junction table. So you have an entity for students, you have a table for courses, and then this is junction table student, and the course has the many-to-many relationship. So therefore, you're going to duplicate the primary key from each any table, student ID, and the course number into the junction table. You see that? So this is an example showing that if you have many-to-many relationships, or two tables, two type of records that are in many-to-many relationships, and you combine them into one table, then you're going to create a problem. You're going to create the second normal form violations. All right. So let me say whether that. So this is an example. Okay. So we did that. Now, second number violations, I already stated that. So by combining entities that have many-to-many relationships, or combining two entities that are connected by associative entity by gerund. Okay. And for second normal form violations, the way we just listed a three-step procedure to fix, list every part of a primary key, and then put all the columns that depend on each part, and then use each line to make a table. So if you follow the procedure, the happy news for the procedure is that the result is clean. So that means you only need to do once. So the end result will be in second normal form. Okay, so you do not need to check again. So for second normal form, fixing is clean. Okay. Anybody has questions at this point? No question? Now, if there's no question, then we'll go to third normal form, okay? So what is a third normal form violation? Third normal form, by definition, is this. First of all, it has to be second normal form. So you say that the first, second, fourth, basically just each depends on the previous one, okay? So third normal form depends on the first one. Third normal form depends on the second one. So if a table is not in the first normal form, then it's not going to be second normal form. Of course, it's not going to be third normal form. So in other words, third normal form is stronger, it's more stringent than the second one. Okay, a table may be in second normal form, however, may still be in violation, may still have extra redundancies according to the third normal form. So it's progressively more stringent. You see that? Okay. So third normal form so you have to be second normal form. Then what is essential ones for third normal form? The essential condition is that there should be no transitive dependencies. Like A depends on B, and B depends. A determines B, and B determines C. So if you have a table with three set of columns like A, B, C. A, B, C, which is, you can think of them as one column, or sometimes A may be several columns, okay? B may be also several columns. So if a set of column A determines set of columns B, and then you have, that B also determines another set of columns C, then this is called a transitive functional dependency. If you have such situation, then the table will not be in third normal form. So third normal form says that you should not have this kind of transitive dependencies. You should not have these transitive functional dependencies. Okay, there's terminology here. There's a what is transistor? B is transistor. We call B a transistor. It's just like A determines B, B determines C, right? So B is something in the middle that determines, coming from determined by others, and then determines something else. A, B is determined by A, and B determines C. Okay, so you see that the transitive relationship. And if this does not does not make sense, if you try not to understand that, I have alternative condition for that. Alternative, you can say this. So there should be no non-key column that depends on another non-key column. Okay, so if you use this one, that's probably easier to use. This definition, second part, equivalent definition, is easier to apply. So basically, you just check to see whether there's a non-key column determines another non-key column. If there is one, then you can say that table is not in third normal form. Okay. Now, how do we check for violations? The first one, of course, we need to know what is the primary key for the table. Okay, and then you draw functional dependencies, and then you check to see whether there is any functional dependency between non-key columns. So put key columns away, and then look at other columns to see whether you have a non-key column determines another non-key column. If there's one, then this table is not in third normal form. If there's one, then you say that that the table violating the third normal form. In this case, we also have a shortcut. That is, if a table has no or non-key columns. So if a table has no non-key columns, everything is a key column. Or if a table has only one non-key column, then there will be no functional dependencies between non-key columns for sure. So in that case, the essential condition for third normal form is satisfied. Okay, so we will encounter that situation that table just, for example, Durand. So for example, junction table does not have non-key columns, right? Everything is key column. So in that case, junction table should be in third normal form. Okay. And then of course you have to make sure that it's in second normal form first. Okay. And Durand, if Durand has only one non-key column, then that it should be also automatically third normal form. Okay, now let me use an example to demonstrate to show how we apply, how do we do fiction. Okay, so now let's assume that each book, okay, each publisher has many books, right? But each book has one editor assigned, okay, and each editor has one phone number, right? So we have a table like this. So title, the book title, book title ID, and the title, and then the title ID, the editor name, and the phone. Okay. So now in this case, this table should be in second normal form automatically because the table has only one key column. Do you remember the shortcut for second normal form? If a table has only one key column, then it should be automatically second normal form. Okay, so we have a situation like that. So this table is already in second normal form. The primary key is title ID, right? Because if you know title ID, then you should know the title, you should know who is the editor, and also the editor phone, right? So title ID determines everything else. Make sense? So this table is in second normal form. However, we are going to check third normal form. So primary key is title ID. Now let's draw functional dependencies. Okay, so first we say that title ID determines everything. Okay, so we have those functional dependencies here. Title ID determines title, editor, and the phone. But editor name also determines the phone also. So each editor, remember, each editor has a phone number, right? So if you know the editor name, then you should know his phone number also. So there's a functional dependency here. And this is non-key column. This is also non-key column. You see that? So therefore this have functional dependency between non-key columns. So therefore this table is not in third normal form. Okay, if we're trying to use transitive dependency, this is called the transitive. Okay, so title ID determines editor name, right? Title ID determines editor name, and then editor name determines the phone, right? So therefore, editor name is actually transistor between title ID and the phone. So this table also, so that's why I said that's the equivalent definition. If you have non-key column determines another non-key column, you can use that to make a judgment to say that table is not in a Thorne normal form. But in this case, we also have such, we can also use transitive dependency here. Okay. Now, so we make judgments. So there's transitive functional dependency with editor name as transistor as follows. So title ID determines the editor name, and editor name determines editor form. Therefore, this table is not in Thorne normal form. Okay, if we use equivalent definition, there's a functional dependency between two non-key columns, right? So this is editor name determines editor form. Okay, so based on either one, we can make the judgment say that table is not in Thorne normal form. So now let's say how can we fix it? Okay, how to fix? So this is how we fix it. Single out each transistor along with the columns that depend on the transistor to make a new table. So this is transistor, form determines on it. So we use that functional dependency to make a new table. So that new table will have editor name, the determinant as a key, and the form will be non-key column. Okay, so based on this transistor, and is the columns that depends on the transistor to make a new table. This table is produced. And now everything else from the original table. So what was the original table? Everything else include title ID and the title, right? So let me just go back to the previous slide. So if you, previous one again. So if you take off these two columns, editor name and the form, then title ID and the title will be just everything else. Everything else plus the transistor, you have to add a transistor back to make a new table. So this is the second step. So original primary key and the remaining columns along with all the transistor form another table. So we have title ID, title, that was everything else, plus transistor. Okay, make transistor back. So now we have a new table that will be title ID, title, and editor name. Okay, so make a new table. Now, if I try and ask you what is relationship between these tables, apparently this is a primary key duplicated here as a foreign key. So essentially you have one-to-many relationship between editors and titles. Between editors and titles, there's a one-to-many relationship. So therefore you duplicate the primary key from editor to the titles as a foreign key. So when you're combining one-to-many relationships, then you're going to create Thorne normal form violations. So this is essentially. Now, for Thorne normal form, the fixing is not clean. Fixing is not clean. So that means the end result can be still in violations, can still violate the Thorne normal form. So you need to check again. So let's check again. First table should have no problem because we have only one key column and one non-key column. If a table has only one non-key column, I said the Thorne normal form is automatic, right? Because there will be not non-key column depends on another non-key column. But then the second table has two non-key columns and only one key column. So second normal form is okay, but Thorne normal form we need to check. Where title determines title, editor name, or editor name determines title. Could be either one because if a book have multiple titles, if a publisher has multiple titles, okay, they may have different editors, right? So title cannot determine editor, editor cannot determine title. Because one editor may have may edit multiple books. Okay, so title cannot determine editor, editor cannot determine title. So therefore, in this case, we do not have non-key column determines another non-key column. So this table is fine. This table is in Thorne normal form. So now the end result is clean. Okay, but it's not always. Okay, so end result is this by splitting this into two tables. Okay, the first one is coming from transistor and the form. Form determines transistor, right? And then everything else plus the transistor make a new table. So this will be the end result. Okay, so Thorne normal form violations is due to combining two entities that have one-to-many relationships, and or maybe also combining two or more entities that have a chain of one-to-many relationship. For example, entity A has with B has a one-to-many relationship. B and C also have one-to-many relationships. So if you're combining those three entities, three set of records together, then you're going to have also Thorne normal form violations. Okay, And the fix to third normal form violation is not clean. The result subtables may still be in violations. All right, let's see what time is it. Okay, so we have like 10 minutes, so that's good. So we can do one more example, okay? We do one more example on third normal form. Assuming that each job has a job class. Okay, so just simplify the way. Maybe each job has like a blue collar job and a white collar job, right? So job class, and which in turn has specific charge hours. So maybe some companies have a rule that, say blue collar job will report work at 8 o'clock and leave the job at 4 o'clock, and then white collar job may report the job at 9 o'clock and leave at 5 o'clock. Okay, so basically, may have each job belongs to a job class, and then you may have multiple job class, but each job class has a specific charge hours. Okay, so now let's look at this table. The table has employee number, employee name, job class, and charge hours. Okay, so what would be the primary key? Of course, the employee number, right? If you have employee number, the employee number determines employee name, job class, and job hours. So the primary key is job number. Okay, so let me try to use whiteboard to finish the example. Okay. Okay, let's see. So we have, primary key we already said will be employee number. Okay, now let's draw functional dependency diagrams. So employee number and employee name, job class, and the charge hours. Okay, so employee name is a primary key that determines everything else for sure. Okay, but then this table also have other functional dependencies. So we have like so if I know job, then I should be able to tell job class and also charge hours, right? Make sense? Okay, so because of that, now this job is non-key column, but the non-key column determines other non-key columns. So therefore, this table is not in third normal form. Is violating third normal form. Okay, so how do we say that? So this table, the table is not in third normal form because of the following transitive functional dependency. So what is the transitive functional dependency? We say that employee number determines job, and job determines job class. Okay, so therefore this table is not in third normal form. Now how do we fix this? So basically for each transistor, the job, you did say what, so which column depends on the transistor. So we say that job class depends on it, and the charge hours also depends on it. Okay, so from that we are going to make a table, use job as primary key, and job class, and charge hours as non-key columns. So that is step one. Step two, everything else. So remember, everything else was employee number plus employee name, right? That's everything else from the original table. So everything else except these three columns, okay? But then you still need to put the transistor back. This transistor has to come back here. Okay, make another table. So now you end up with two tables. So a job class, charge hours, employee number, name, and job. With the original primary key will be still primary key for the remaining table. So the end result is splitting that into two tables. Okay, now The example is similar to the one we had before, but this one, the result is not clean. Let me check, okay? So first of all, we check employee, this second table. The second table has two non-key columns, name and job. Do they depend on each other? Job determines name, of course, no. Name determines job, also no, right? Because many people have the same name. We have different jobs, okay? Okay, so that's this table is fine. So this table is already in Thor normal form. But what about this table? Now this table, we have also two non-key columns. We have job class and charge hours. Clearly, there is a functional dependency between charge hours and office hours and the job class. So if you know job class, you know the charge hours. So therefore, this table has functional dependency, has a transitive functional dependency, because job determines job class and job class determines charge hours. So therefore, this table is not clean. So we need to fix that again. So to fix that, we need to use the new transistor job class, which determines charge hours. So make the new table with both job class and the charge hours as columns. And then job class as transistor, the transistor will become primary key. So that is coming from this table. Okay, and then next, everything else in this case just have one table, one column, job. Okay, everything else, which is job column, okay, plus transistor. So everything else plus transistor. So you need to put a transistor back. So this transistor has to come back to here, job class. Job class as a foreign key. Okay, so then this essentially the original one table is now split into three tables. This table, employee table, job table, job class table, and they have one-to-many relationships between job and job class, between job class and job, and between job and employees. All right, make sense? So therefore this this example shows that we may have a situation that we have to split again if you have Thor normal form violations. Okay. All right. Now let me see whether anybody has questions at this point. I think we still have three more points, three more questions. I'm going to stop recording first.